Welcome to ZK Vibes, your trusted source for the latest breakthroughs at the intersection of zero-knowledge cryptography and real-world innovation. In this episode, we're diving into a cutting-edge development in the world of AI trust and verification. As AI becomes more deeply embedded in decision-making, the ability to verify its outputs, without compromising data privacy, is no longer a luxury, it's a necessity. Today, we'll explore how Provably is making that vision a reality with their novel proving technique. As AI agents become integral to our daily workflows, managing finances, assisting in decision-making, and more, the question arises, how can we trust the outputs they provide, especially when these outputs are based on private data? Traditional AI models, particularly large language models, are prone to hallucinations, generating information that appears plausible but is incorrect or fabricated. While grounding techniques, which tie AI outputs to real-world data, help mitigate this, they don't fully address the trust issue. Users still lack a mechanism to verify the correctness of AI-generated answers, especially when they can't access the underlying data. Provably's proving technique addresses this gap by leveraging zero-knowledge, ZK proofs. This method allows AI systems to provide cryptographic proofs that their computations, such as SQL queries on private databases, are correct, without revealing the underlying data. How it works. User query. A user poses a natural language question. Translation to SQL. The AI agent translates this question into an SQL query using advanced techniques like retrieval-augmented generation and chain-of-thought prompting. Execution and proof generation. Provably's middleware executes the SQL query on the relevant database and generates a ZK proof certifying the correctness of the result. Response delivery. The AI agent returns the answer to the user, accompanied by the ZK proof and metadata detailing the query, data source, result, and timestamp. Verification. Users can independently verify the proof in seconds, ensuring the answer's validity without accessing the private data. Implications and use cases. This approach has profound implications. Enhanced trust. Users can trust AI outputs, knowing they are backed by cryptographic proofs. Privacy preservation. Sensitive data remains confidential, as proofs don't expose underlying information. Versatility. Applicable in various domains, from generating invoices to complex financial analyses like loan origination. Provably currently supports PostgreSQL and is expanding to other databases. Their roadmap includes handling larger datasets and more complex queries, aiming to make verifiable AI a standard across industries. That's a wrap for today's deep dive into Provably's approach to verifiable AI. Zero-knowledge proofs are evolving from theory into indispensable tools for trust, privacy, and transparency, and this is just the beginning. If you enjoyed this episode and want to stay ahead of the curve in the ZK space, make sure to follow us on ZK Vibes Twitter for updates, insights, and more conversations like this. Thanks for tuning in, and keep riding the ZK wave.